In the 1950s, it was believed we knew more about the surface of the moon than the deep seas on Earth. Since then, humans have landed on the moon's surface and have dived nearly 7 miles in a submersible to the ocean's deepest point. Scientists continue to make discoveries about both extreme environments, but so far, only one has been found to support animal life, and those creatures will haunt your dreams. Hi, I'm Erin McCarthy, editor-in-chief of Mental Floss, and today we're going to meet a few of the organisms adapted to the dark, cold, pressurized environment of the deep sea, from a ginormous relative of the garden pillbug to fish with translucent heads. Let's get started. First up is one of the strangest critters of the deep. A giant Larvacean has a tadpole-shaped body only an inch or two long. You may be wondering why it's called a giant Larvacean, and it comes down to its unique way of eating. This gelatinous tunicate, a type of marine invertebrate, envelops itself in a coating of mucus, also known as a snot palace, that can measure more than 3 feet in diameter, and it uses this snot net to catch drifting food particles. The mucus can snag carbon-rich marine snow as well as microplastic, and when it gets too clogged with inedible stuff, the giant Larvacean discards it. The blob then falls to the ocean floor where other animals eat it, and a new mucus house is grown. As revolting as this picture may be, you should thank a giant Larvacean. They actually help fight climate change by collecting and sequestering a ton of carbon from the ocean in their mucus. According to a 2017 study by scientists at the Monterey Bay Aquarium Research Institute, published in the journal Science Advances, giant Larvaceans can capture more carbon than any other filter-feeding zooplankton. Thanks, big guys. The common fangtooth, a tiny fish with a formidable bite, is found worldwide in tropical and temperate waters between 1,600 and 6,500 feet below the ocean's surface. It's also been spotted at a depth of 16,000 feet. That's as deep as a stack of 52 statues of Liberty, including the pedestals. But its signature feature is its mouthful of dental daggers. The fangtooth has the largest teeth of any marine species relative to body size. They're so big that the fish can't even close its mouth properly. Instead, it's evolved 2 sockets on either side of its brain where the bottom teeth slide in when the jaw's shut. So why does this little guy need such big teeth? Scientists think that they might be an adaptation to living in darkness in a food-scarce environment. The giant chompers allow the 6-inch fish to grab onto anything unlucky enough to pass by, even prey much larger than itself. The same explanation may apply to deep-sea creatures like viperfish, dragonfish, and anglerfish, which are their own kinds of nightmares. In biology, Bergman's rule states that smaller species tend to live in warmer climates, and larger species in colder environments. Case in point, the giant Isopod, a marine arthropod related to the much smaller, friendlier garden pillbug or roly-poly. These benthic beasts can grow over a foot long and are commonly found 7,000 feet below sea level, where they hunt smaller creatures and scavenge whale falls and other foods drifting down to the seafloor. I think they're super cute. Scientists don't really know why they're so big. Their relative hugeness could be an adaptation to their cold, highly pressurized habitat, a theory called abyssal gigantism, which also falls in line with Bergman's rule. Another weird fact: though giant isopods are found in most regions of the world's oceans, all individuals are physically identical, which suggests a lack of evolution, even though they've been around for about 160 million years. This characteristic might be a product of their low-light environment, or maybe they just love themselves, exactly as they are. The Gulper Eel, also called a pelican eel, is roughly 1 meter of tail and mouth. This unusual fish, the only species in the genus Uropharynx, slinks through the water as delicately as a rhythm gymnast ribbon. But its streamlined profile and uniform coloring disguise its main feature, an absolutely gigantic mouth. The eel's tiny eyes aren't much help with hunting in the pitch-dark sea, so it relies on a bioluminescent organ at the tip of its tail to attract prey. When it locates a small fish or crustacean, all bets are off. The eel's massive jaws swing forward and its mouth opens to a diameter many times that of the rest of its body to literally gulp its prey. The skin of its cheeks and throat are so flexible that its entire head can blow up like a balloon, giving the Gulper eel the shape of a lollipop and allowing it to engulf prey much larger than the eel itself. Because they live at depths between 900 and 7,000 feet and don't often come closer to the surface, Gulper eels are rarely encountered in the wild, but they occasionally get swept up in commercial fishing nets. I, personally, would be perfectly content if I never saw one with my own eyes. Scientists were not aware of the existence of deep-sea hydrothermal vents until 1977, when researchers discovered an area of the super-hot, mineral-rich springs bursting from the seafloor near the Galapagos Islands. Even more exciting, encountering bizarre animals like the giant tubeworm, thriving in what was thought to be an uninhabitable environment. There were colonies of giant tubeworms crowding the vents. The 6-foot invertebrates are the heaviest worms and one of the fastest-growing species on Earth. They lack mouths and digestive systems. So instead of eating, the worms harbor symbiotic bacteria in their bodies that transform the vent's hydrogen sulfide emissions into energy. If the worms feel threatened, they can retract their red feather-like gills inside the protective white tubes surrounding their bodies. Thanks to their incredible adaptations, these extremophiles and the ecosystems they support may give us insight on how life could exist on other planets. Giant worms living on an alien planet. There's something there. Imagine being a salp, a type of marine invertebrate that is basically a handful of transparent goo with a brain. One minute you're minding your own business, efficiently using jet propulsion to move about the water column, and the next minute you're getting eaten alive by a barrel amphipod. Salps are no match for these inch-long shrimp-like crustaceans. Barrel amphipods depend on salps for food and shelter in a deep-sea environment with few places to hide. First, the amphipod snags a passing salp with its sharp claws. It eviscerates the salp and eats its guts, then climbs inside the hollowed-out invertebrate, ensconcing itself in its new abode, aka barrel. But they don't settle down. The creatures take their barrels with them wherever they go. These amphipods can even remodel their homes by secreting chemicals that strengthen the gelatinous structures. Because when you live more than 2/3 of a mile below the surface of the ocean, housing is at a premium. Before we meet our next guest, let me first say that we are not making its name up. The bloody belly comb jelly really is called that by actual scientists. These 6-inch Kong-shaped globs are deep red to hide themselves in the twilight world, where red coloring acts like a camouflage against the darkness. It's a necessary adaptation because the bloody belly comb jelly's favorite foods are bioluminescent. Without its red disguise, the comb jelly's predators would be able to spot its meals glowing through its semi-transparent stomach. These comb jellies are bioluminescent too, and may use these signals for communication or as a defense mechanism. Whatever light is available in the ocean's depths diffracts and refracts off its hair-like cilia, which resemble tiny combs arranged in rows up and down the jelly's belly. The movement of the cilia help the jelly swim, and make it light up like Times Square. We've met quite a few semi or fully transparent denizens of the deep, but the Barreleye fish takes it to the next level. The back half of this guy looks like your average 6-inch fish. The front half is a different story. The top of his head is completely see-through, revealing its eyes and brain encased in a fluid-filled bubble. 2 indentations at the top of its head, which look like they should be eyes, are actually the fish's olfactory sensors. Its eyes are bright green and barrel-shaped, hence its name, and point straight up. The green hue might filter out certain wavelengths of light and aid them in seeing other creatures' bioluminescence. Research dives by the Monterey Bay Aquarium Research Institute in 2009 revealed that the fish can also rotate their eyes to face ahead, which probably helps them forage for zooplankton more accurately. But why it developed such extreme adaptations to life in the ocean's twilight zone is still a bit of a mystery. Let's head back up to the surface and away from these beautifully terrifying creatures. Thanks for watching this episode of The List Show, and I hope you don't have any nightmares tonight. See you next time.